Chapter 2, Graphs, Charts, and Tables, Describing Your Data. In this video, we'll cover frequency distributions, histograms, as well as joint frequency distributions. A separate video will show you how to do these in Excel. A frequency distribution is a summary of a set of data that displays the number of observations in each of the distribution's distinct categories or classes. So here we have an example. Imagine you're an employee at Petco and you want to know how many pets your customers have. So you ask 20 customers how many pets they have, and we take a tally of how many individuals say they have 0 pets, 1 pet, and so on. So here on the right we have our column for frequency, where we've turned our tally marks into numbers, and we can see how many customers have 0 pets, as well as how many customers say have 4 pets. With frequency distributions, what we are working with is discrete data. This is data that can be counted. For instance, we can count how many students are 25 years old. We can count the number of courses you're currently taking this semester. We can count how many late deliveries the pizza delivery person made last month. And we can count the number of touchdowns scored in Sunday's game. Now, with the frequency distribution, we often want to calculate the relative frequency. So this is the proportion of total observations that are in a particular category or class. So to calculate the relative frequency, we take the frequency of the value that we're looking at of a particular variable and then divide it by the total number of observations. So let's see an example. In step 1, we've listed all of our possible values under the column that says number of pets. Right? People could say 0 pets, 1 pet, 2 pet, 3 pet, 4 pet. In step 2, we counted how many people have that many pets. So under the frequency column, the second column, it shows 4 people have 0 pets, 6 people have 1 pet, and so on. And we can see that we have a total of 20 in our frequency. So then in step 3, to calculate the relative frequency, we take our frequency of a particular class or category, in this case 0 pets. There were 4 people that said 0, and we divide it by our total number of observations, the 20 customers that we surveyed. And we take those and we divide to get the relative frequency. So 4 divided by 20 gives us 0.2. And so we'll do that for each discrete variable. In this case, how many people said 1 pet? We'll take 6 divided by 20 gives us 0.3. How many people said 2 pets? We'll take 5 divided by 20, that gives us 0.25, and so on. When you add all of the relative frequencies together, it should equal to 1. That way you know that you've done it correctly. If when you total them up it does not equal to 1, then you may want to go back and double check your math. Now in that example we saw it was very simple with our discrete variables. We just had the number of pets 0 through 4. With a lot of data that's collected, the variable of interest could be continuous or discrete, in that we have a much larger data set and we'd have to group it. So with continuous data, the values are uncountable, and it can be any value in an interval. For instance, weight, length, or time. So with weight, I can say something weighs 20 pounds. I can also say something weighs 20.25 pounds. And I can get very granular with the data, hence it's continuous. With discrete data, recall it's where we count, and again, it can have many possible outcomes, but at least it's countable. So how many students have a 4.0 GPA, for instance? To work with large data sets, we want to group them into something more manageable, and they're known as classes. To build classes, you have to make sure that they're mutually exclusive in that they do not overlap. They should also be all-inclusive so that our set of classes contains all possible data values. Nothing gets left out. Classes should also be of equal width or distance, so the shape of the bars that we will see are even, and there should be no empty classes. So for instance, here we have a distribution of temperature, and it's actually too many classes. Even though the width of the classes are equal or evenly distributed, we see there's too many so that we can't really see a good shape, and we have an empty class here at the 52-degree mark. In this example, same data set, we have too few classes so that we can't really see the distribution. It's just one big blob in the middle. So how do we build our classes? In our textbook, there was an example of the frequency distribution of streamed movies. So we have answers from 0 movies streamed all the way up to 30 movies streamed. And so I had to cut the table in half to get it to fit on the screen. But as you can see, if we count up all the frequencies of people, we've got 230. So to determine the number of classes, a good rule of thumb is that we want it to be somewhere between 5 and 20 classes. And we use this rule of 2 to the exponent k should be greater than n, where k is the number of classes that we're going to use, and it should be the smallest number possible, where when you do 2k, it will be greater than our n, and n is our number of data values or observations. So recall in that example with the movies, 230 was the total, so we'll have 2k must be greater or equal to 230. So here you're actually going to use trial and error. Let's try 5, because remember rule of thumb is between 5 and 20. So if I take 2 exponent 5, I get 32. 32 is not greater than 230, so we have to keep trying. Since 32 is so small, I'm going to jump to 7. So if k were to equal to 7, if I take 2 exponent 7, I get 128. That's still less than 230, so we'll try one more. Let's try k equals 8. When I take 2 exponent 8, I now get 256, which is greater than 230. So we know that we need at least 8 classes for our frequency distribution. Now we want to establish the class width. To do that, we take the largest value, in this case it was 30 movies being streamed, and the smallest value, which was 0, and we'll divide it by the number of classes that we figured out in step 1. So when we take 30 minus 0, which equals 30, and divide it by 8, we get a width of 3.75. To make it easier when we work with our data, we'll round it up to a nicer class width of 4. So in step 3, we'll create our boundaries for each class. So the first class will be between 0 and 3, and if we count 0, 1, 2, 3, that's 4 right there. That's a width of 4 numbers. Our next class is between 4 and 7, 8 and 11, and so on. So as you can see, we're not missing any numbers and we're not overlapping any numbers. So on the left, we have the lower end of our classes, and on the right side, we have the upper end of our classes, and they should be even. In step 4, we'll go ahead and tally up the frequencies for each class. So we'll add up all the frequencies of 0, 1, 2, and 3 stream movies, which gives us 60. What's the frequency of 4, 5, 6, and 7 movies is 50, and so on. So again, when you add these all up, you get 230 movies, but now you have them grouped in intervals. So this is a graph that displays the frequency distribution of what we just set up. Down below are the possible outcomes. So these were the classes that you had come up with, 0 to 3, 4 to 7, and so on. And on the left here in the y-axis, we have the frequency for each possible outcome. Recall there were 60 that identified 0 to 3 movies, 50 for 4 to 7, and so on. So this is how we display a frequency distribution, and it's known as a frequency histogram. So what does a histogram provide us? It tells us where the center of our data falls within a number line. It shows us the spread, or how wide it goes, and it shows us the shape. Is it symmetrical? Is it skewed? Next is the joint frequency distribution. So with joint frequency distributions, what we're trying to do is understand data that has 2 variables. It can be qualitative or quantitative, but the steps here is first we'll collect the data, then we'll create a table, and then count the joint occurrences and enter it into the table, and then figure out the totals. So let's see an example. In our text, we had 12 customers who were parking their car. They either charged the parking cost or they paid cash, and they were parking in a particular parking garage. So we've got two variables we're looking at, the payment method and which garage customers went into. So here I'm going to have the data here on the left for ease, and we create our table here where we've got one variable, charge or cash, on the left, and the other variable, which is the parking garage, up at the top. So I'm going to count how many people in parking garage 1 charged their credit cards. So we can see we've got 1, 2, 3, 4 people that parked in parking garage 1 and charged it. Then we'll take a look at how many people in parking garage 1 paid with cash. So we'll look through until we see 1, 2. And then let's go ahead and look at parking garage 2. How many people charged? 1, 2. And how many people paid with cash? 2. And then we'll do the same for parking garage 3. We have 1 cash and 1 charge. And then what you'll do is you will total up. So in this column right here for parking garage 1, we have 6 customers. In parking garage 2, we have 4. And in parking garage 3, we have 2. And then we also have to total up across the way how many people charged a credit card. We've got 7. How many people paid with cash? We have 5. And then we also want to total our subtotals. So 7 plus 5 is 12, as well as 6 plus 4 plus 2 is also 12. So that gives us our 12 customers that we were analyzing. So that's how you'll use a joint frequency distribution when we are looking at two variables. This is also helpful when we're trying to figure out probability, which we'll learn about in Chapter 4.